Alright, family. In this video, we're going to revise this question that came under magnetism in physics, which is science paper 1. The question says, figure B6.1 shows magnetic field lines between the poles of two magnets. Okay, so we have been given the magnetic field lines between the poles of two magnets. Okay, so the first question here, which is question A, says name point R. Okay, so this point R here is known as neutral point. P says if P is south pole, what are the poles Q and T? So if P is the south pole, then what are the poles Q and T? Okay, Q and T. Now what you need to understand here is that north pole always releases magnetic field lines. Then the south pole receives the magnetic field lines. For example, what I'm trying to say here is that whenever you have a magnet, let's say this is a magnet and then this is a south pole and this is a north pole. One of the ways you'll be identifying to say this is the north pole, you need to understand that the north pole releases magnetic field lines. So you'll be having something like this. A north pole releases magnetic field lines, as you can see here. Then the south pole, this one here, the south pole, we can say it actually receives the magnetic field lines. Okay, it receives magnetic field lines. So please, whenever you are told to identify the poles of a certain magnet, try to look at the direction of the magnetic field lines. Okay, try to look at the direction of the magnetic field field lines. So here we have already been told to say if P is the south pole, then what are the poles Q and T? So as you can see, Q here is actually releasing the magnetic field lines. So since Q is releasing magnetic field lines, then we can tell that this is a north pole. Okay, this is actually a north pole. And then here for T, we are going to look at this magnet here. As you can see, S is releasing magnetic field line. So we can tell that even S here, this is a north pole. So if this is a north pole, then T will be a what? A south pole. Okay, T will be a south pole. All right. So from here we can conclude that this one here is actually a south pole. Then this is a north pole. Then this is also a north pole, and this is also a what? A south pole. And that's a reason why we are having what? Repulsion here. That's a reason why we are having repulsion, because these magnets, they have the same what? The same poles. So you always need to remember this. You always need to remember this. Same poles repel. Same poles repel, which is also known as repulsion in short, takes place whenever you have the same poles. Magnets of the same poles, repulsion takes place. Then different poles, they actually attract. Okay, different poles they attract, which is also known as the attraction. And in a repulsion, that's where we have a neutral point. Okay, a neutral point is always formed in repulsion. Okay, in case you want to understand the structure, repulsion may look something like this, just like the way we have been given here. This is repulsion. As you can see, these magnetic field lines, they are not attracted, so meaning that this is repulsion. This is actually showing the repulsion taking place. Then for attraction is formed whenever you have magnets of different poles. Okay, whenever you have magnet of different what? Poles. Let's assume this is south pole, then this is north pole, then this is south pole, then this is north pole. In this case, you are going to have what? Attraction. Why? Because these magnets, they have different poles. As you can see, this is north pole, this is south pole. So we are going to have repulsion taking place, or we are going to have attraction. And to show that this is attraction, remember, north pole releases magnetic field lines. So we are going to have something like this. Okay, so this is now what? Attraction. Don't forget, we are Kia and we offer both physical and online lessons. The number is 0974 980775. Kia, thank you so much for watching.